Hi everyone, my name is İlhan. My department is physics. This is my physics 102 lab project video. In this video, it will be examined how the change in resistor length will affect resistance. Thus, an understanding will be developed about one of the parameters on which the resistance depends. First of all, I want to talk about the theory behind the experiment briefly. The theory behind the experiment comes from a microscopic examination of a conductor. As you can see, this formula gives a relationship between electric field and the current density. Current density is defined as the amount of charge per unit time that flows through a unit area of a chosen cross-section, and represented by the letter J. If we want to find the total current through a surface, we have to integrate the charge density with respect to area of the cross-section. In addition, we have this formula for the potential difference between 2 points, and it follows that the potential difference equals the electric field inside the conductor times length of the conductor. Lastly, we know that the resistance can be written as the potential difference divided by the current from the Ohm's law. If we write the potential difference as the electric field inside the conductor times length of the conductor and the current as a current density times area of the cross-section, we reach the following formula. Thus, from the final form of the formula, we see that the resistance depends on the geometry, and in this experiment, we will examine the relationship between the resistance and the resistance length to verify this formula. In this experiment, the instruments that I used can be listed as a multimeter, a 30-volt direct current power supply, cable sets, a rheostat, which is adjustable resistor, a ruler, a scientific calculator. Now, I want to mention the experiment itself. I built the circuit shown in this circuit diagram. I put the multimeter into ammeter mode to measure the current, and I applied a constant potential difference of 10 volts to the circuit. Then I increased the rheostat slider evenly and gradually by 5 cm and collected the current data for each R value on the ammeter. I entered the data I obtained into the table and calculated the theoretical resistance value using the formula we obtained and the maximum resistance value written on the rheostat, which was 110 ohm. I plotted these graphs using Python in accordance with the data processed in the tables. Then I calculated the slopes of the best fit lines of the graphs. As can be clearly seen from the graph, I concluded that there is a directly proportional relationship between the resistor length and the resistance. So it shows that the result of the experiment is compatible with the formula that we derived before. Thus, the experiment achieved its purpose, and it was learned that the resistor length is a parameter of the resistance. Finally, the percentage error was calculated based on the experimentally obtained resistance values and theoretically obtained resistance values. And thus graph number 2 was drawn. The slope value of the best fit line was found to be 1.10, considering that the slope value of 1 is completely compatible with the theory and the experimental result. The value of 1.10 shows us how close the result of the experiment is to the theory itself. Thank you for listening to me.